partial fraction, we will decompose this fraction into little fraction. So before we do anything, we have to rewrite the denominator, because x squared minus 1 can be factored further, which is s minus 1 and s plus 1. And so we have two factors of s minus 1 and 1 of s plus 1. Right, now we do the decomposition of that. For s plus 1, that will be easy. But for s minus 1 square, we have two factors of s minus 1 square. Two factors of s minus 1. So we have one of them has s minus 1. The other one is the factor of s minus 1 square. If this is a cube, then we also have s minus 1 cube. But that's not what we have. So even then, the top is just a constant, because degree on top cannot be more than at the bottom for the first term, and the square head will be the same. For s plus 1, we have s plus 1 at the bottom. On the top is also a constant, because degree must be 0. Right. We will multiply both sides by the least common denominator of s minus 1 square and s plus 1. So it will cancel the denominator. On the top, we just have 2s. Actually, just have 2s on the left hand side. A times s minus 1, s plus 1, plus b, s plus 1, plus c, s minus 1 square. And we just multiply them out and combine like terms. So I multiply the s minus 1 and s plus 1. That is s squared minus 1. And the s minus 1 square, that will be s squared minus 2s plus 1. Now multiply it out and combine like terms. I'll just group all the terms together. Actually, just multiply it out first. Now combine like terms. For s squared, we have as squared and cs squared, so we have a and c. A plus c s squared. And for s, we have bs minus 2cs. And then the remaining are constant, a plus b plus c. Actually, that is minus a plus b plus c. That are constant. Now all we do is just match the coefficient. We do not have anything on the, do not have s squared on the left hand side. So the equation is a plus c must be 0. And the coefficient for s on the left side, we do have 2s. So we have b minus 2c equal to 2. We have to match the coefficient. And then the left hand side has no constant. So we will have negative a plus b plus c equal to 0. And that is the system of equation we have. I'm going to use the calculator to solve for this system of equation. So if we put in the matrix form, that will be 1a, 0b, 1c, the left hand side 0, 1b, negative 2c, left hand side is 2, negative 1a, 1b, 1c equal to 0. And we just do reduced row echelon form. Right, so we have a calculator. Let's move that here. Right, so second and matrix, go to math and go down to the reduced row echelon form. And we apply that to a matrix, alpha, zoom. I have to hit alpha and then zoom. It has 3 rows and 4 columns. And we enter the coefficient 1, 0, 1. Make sure you don't hit enter in this case. Just hit the arrow. Go next. 0, 1, negative 2, 2, negative 1, 1, 1, and 0. We do the reduced row echelon form and turn that to fraction. Let's just put that somewhere. Right. So we will have the left hand side is the identity matrix. One half, 1, and negative 1/2. So which means A is 1/2, B is 1, and C is negative 1/2. Right. Now we can put it back into this form. Put this coefficient back into this, and we have the decomposition of that. So let's just write. On the left hand side, we can start from the beginning, the original prompt. So that will be 2s over s minus 1, s squared minus 1. On the right hand side, we will have a over s minus 1. A is 1/2, s minus 1, plus b is 1 over s minus 1 square, and minus 1/2, so I just say minus 1/2, s plus 1. Of course, we can rewrite as 1 over 2. In the interest of do the Laplace transform later, it will be better if we write just write the next line. It's better just write 1/2 like this, so in later when we do the inverse transform, it will be easier to do after that. Right, and so let me zoom out so you can see the whole prompt. Yeah. So that's what we have. Just decompose, but make sure that we factor the denominator completely, and just write out the individual forms of the decomposition. And after that, we just eliminate the denominators and solve for the coefficients. And yeah, so the answer should be in this form.